Hey everybody, Mr. Odom here, and today we're going to work out a problem from section 3.2. So make sure you got your pencil, composition book or notebook paper to take notes, and a calculator if you need it. It's a good tool to have handy. So let's go through, the learning target for this video is that you can apply properties of operations to add and subtract linear expressions. All right, so let's go through this problem. Taxi Express, they charge $2.60 plus $3.65 per mile. So if you grab one of their taxis, they'll have a meter and it will do the math to tell you how much you owe them. And this is kind of the formula it uses. The cab cruiser charges $2.75 plus $3.90 per mile. So there's an initial fee of $2.75, and then every mile you will give them $3.90. All right, so we want to write an expression that represents how much more cab cruiser charges than Taxi Express. All right, so I'm going to use this problem-solving strategy that I've used before, where we're going to solve a simpler problem first, and then we'll use that strategy to solve this more complicated problem. So let me just make this a simpler problem. So the simpler problem will be Taxi Express charges, let's say, $2 plus $3 per mile, and I'll use M to represent the number of miles. So if you just get in that taxi and go 1 mile, you will owe Taxi Express $2 plus $3 times 1, or that equals $5. All right. For cab cruiser, we'll use the value, again, we'll use $2 plus, and we'll say $4 per mile. So if you go 1 mile in their taxi, you will owe them $6. $2 to just get in, close the door, and then that first mile is going to cost you $4 because M will be 1. All right. How much more does the cab cruiser charge than Taxi Express? Okay, so if let's say we're just going to go 1 mile. So if we just go 1 mile, you're going to pay $5 in the Taxi Express. If you go 1 mile in the cab cruiser, you're going to get charged $6. So how much more does cab cruiser charge than Taxi Express? And to figure that answer out, we're going to take this number and subtract this number. So we'll take $6 and subtract $5 from it. And this tells you how much more cab cruiser charges than Taxi Express just to go 1 mile. Okay, you'll pay an extra dollar. All right, so we're going to use this strategy to help us to solve the more complicated problem. All right, so let's get started. Taxi Express charges this much, $2.60 plus $3.65. Whoops, where'd the 3 go? $3.65 per mile. So every mile, I'll use M as my variable. So this is how much Taxi Express charges. All right. Again, another color here. Let me try this color. Cab cruiser, you're going to pay $2.75 plus $3.90 per mile. Okay. And we want to know how much more does Cab Cruiser charge than Taxi Express? So what did we do? In our simpler problem, we set up a subtraction problem to give us the answer. Guess what we're going to do here, ladies and gentlemen? We're going to do the same thing. We're going to set up a subtraction problem. So this would be $2.75 plus $3.90 per mile minus $2.60 plus $3.65 per mile. All right, so here is the Cab Cruiser and here is the Taxi Express. We want to know how much more does Cab Cruiser charge. All right, well, this is an expression, and we've been simplifying expressions in this chapter so far, so let's go ahead, and this is a subtraction problem. So let's go ahead. Can I drop the parentheses here in the first linear expression? I can, so this just becomes $2.75 plus, and actually I got some things backwards here, didn't I? No, I didn't, I'm good. Plus $3.90 times m, which is the number of miles. And I'm going to subtract. So when I subtract, I add the opposite. So I'm going to add the opposite of $2.60, which would be negative $2.60. And then that's positive $3.65 times m. So that's negative 3, and I forgot my dollar sign. Negative $3.65 times m. All right, are there like terms here? You bet there are. So $2.75 is a constant, and here's another constant, negative $2.60. Here is a term that has the variable m. Here's another term that has the variable m. All right, so let me combine these terms. I'm going to take $2.75 and subtract $2.60 from it. Whoops, let me put a box around that part. Those are my like terms there. And then I have $3.90. And I'm going to subtract from that $3.65. And I forgot the m's here. So let me do some erasing. I'm getting forgetful. Oh boy. $3.90 m times m minus $3.65 times m. So these are like terms. They have the same variable raised to the same exponent. All right, so $2.75 minus $2.60 is just, what is that, 15 cents. And then $3.90 minus $3.65. So this is going to be plus, and this is going to be, what, 35 cents times m. So this would be the difference. There are no more like terms, there's no parentheses. So this represents that difference, just like here, that $1 represented the difference when we were solving a simpler problem. This represents the difference. And I can tell you what the difference is if they travel 50 miles, what would be the difference? Or if they travel, this is miles, or if they travel 26 miles, you could figure out how much more you're going to pay using the Cab Cruiser cab versus the Taxi Express. So this is a pretty powerful expression that can help us depending upon how many miles we travel. Okay, so this is problem number 29 out of section 3.2. If you got questions, please bring them to class, and I hope to see you soon. You guys take it easy. I'm out.